everyone, welcome to another episode of Science Stories. I am Avrajit Bandyopadhyay and I was a PhD student at Indian Institute of Astrophysics, Bangalore. So firstly, I would like to thank Professor Avrajit Bandyopadhyay for this wonderful initiative and for inviting me to give a talk based on my science story and my journey starting with my school, college, doing my masters and finally my PhD and postdoc. Thank you so much, and here goes my science story. So this seemingly long journey started with Nainital school, the local kindergarten school at my neighborhood. So I was born at Howrah, West Bengal, to a Bengali family, and the first study I started was in Nainital school till class 1, and then I moved to St. Thomas's Church School. So the first interest towards science was perhaps kindled by my mother when she used to take me up to the terrace, particularly in the evenings when she got some time after the family stuff and all. And we used to lie down on the terrace and look up at the sky. And the sky used to be so beautiful. So many stars, constellations, patterns in the sky. And I was really astonished. I was very motivated. There are several questions that haunted in my head, like what are these small specks of light? What are these patterns of? What are they made up of? How do we know how far they are? These are some of the very small questions that used to come to my mind. And whenever I asked my mother, she said, it's your job to find out. And there are also stories by my grandmother and others about several mythologies that concern the stars and these planets, like Mars used to rise in the evenings, Venus used to rise in the evenings, Venus used to come back again in the mornings. So I particularly wondered what are stars and what are planets, how are stars different from planets. And then when I grew up further, in class 2, my mother took me to the local public library. So it was a library in the market. It's very old, like more than 100 years old. And there I had access to so many books. I was particularly motivated towards the science fiction genre. Several authors, like, I'd like to first talk about Jules Verne. So Jules Verne was like a stalwart in my eyes. He's a stalwart, but he used to motivate the young minds wonderfully. His stories like Journey to the Center of the Earth, From the Earth to the Moon, where Maston used to build a long tunnel underground that covered 1/3 of the Earth and shoot a projectile towards the moon. And there they use firecrackers to land and to come back to Earth and land on the Atlantic Ocean. So stories by Jules Verne, stories by H.G. Wells, where Caver went to moon and found the civilization under the surface of the moon. And then stories by Tintin, by H.G. Wells of Tintin, like Destination Moon, where they build a rocket and they go to moon, they explore the moon. And the stories of Journey to the Moon, Destination Moon, the wonderful view of the space once they leave the atmosphere of the Earth. Those are very motivating. Those pictures are very captivating. Hand-drawn pictures by her, entirely imagination. And then when I was in class 7 or 8, there are movies coming up which showed the astronauts floating in space inside their rockets. In the Science City, they used to show pictures of Neil Armstrong landing on the moon, the Apollo spacecraft. They're very captivating, they're wonderful. And then another Bengali writer, Avrajit Bandyopadhyay, he used to write stories on a famous scientist, Professor Shonku, who practically discovered anything he wants. He was a scientist, he used to stay at his home and discovered so many things, space shuttles, aeroplanes, aerocrafts, balloons, everything he used to discover, and he was at his own. He discovered so many. It was very, very, very inspiring to read all these stories. And I also thought at the kinder age that one day when I grow up, I shall too be a scientist like someone like Professor Shonku or someone like Maston, or an adventurer like Tintin, or even someone like Jules Verne who could write such wonderful stories that would become true later. So that's how things went on. I used to go at school, but I was not particularly very interested on academics at that point of time. I was more interested in storybooks, listening to stories, adventures, space voyages, all this stuff. So that's how things went on slowly, and I always had this at the back of my mind that one day when I grow up, I shall be an astronomer or an astronaut. Then this way the school went on. In school things went on well, neither very good nor very bad. So once I went through the class 10, the first hurdle, that is ICSE class 10. After that, when I got into class 11, I was selected as a candidate for Quanta. Quanta is an international quiz competition, and our school participated that year, 2006, when I finished my ICSE. And I was selected to represent my school on astronomy quiz, the international astronomy quiz. So that was like a dream come true to be selected from the school, and I was very happy. So there I was given 1 month of time, and the school library opened up. They provided me all sort of support and help, including to catalogs and encyclopedia of astronomy. They had those fascinating pictures like nebulae, horsehead nebulae, crab nebulae. Those are fascinating images to a young mind. The same happened with me, and as I read more and more, as a preparation for the quiz, but that was also a very motivational factor that acted behind my decisions later. So Quanta is obviously one landmark that happened, and we also got a good rank in the international competition, quiz competition. And my teachers like Shudip Chatterjee in my school, Mr. Bhaduri, my physics teacher at school, they all suggested that why don't you take up astronomy later, because you write so well, you studied so well, it's good, you can think about on that lines. However, one teacher I came across in class 11, Shourabh Mitra, he used to teach me physics and mathematics. His home was very close to my home, and he was a very inspirational teacher. He used to make stories out of physics stuff. He used to make stories out of Ohm's law. He used to make stories out of differential equations, explain differential equations in a physical format, outside the mathematics, outside the boring derivations, making use of symbols. He also motivated a lot to take up science as my career. So these two factors, like one was my wish to study astronomy, and the other inspirations from my teachers, like the few I have named, and others which I cannot name in this short format, to take up astronomy as a subject. So when I passed class 12 ISC, then the decision was not to go into engineering. My mother was very supportive of my decision, but my father, since I got a relatively good rank, he was like, why do you lose this opportunity? Engineering is always good for the future. But I was very adamant, and I did not agree to the general opinion, and I took up science. I took up honors in physics and got admitted in the University of Calcutta. Finally, January 2014, and one of my dreams have come true. I was in IIA as a research scholar. Our course is of 5 years, and it's divided into 2 parts. The first year is the coursework. It's a joint astronomy program conducted by IIA, IISc and ARIES. So for the first year, we daily had to travel to IISc for the courses, and the courses were wonderful. They were very illuminating. Yes, at times a bit rigorous, full of derivations, but at the same time, they're all very exciting, and we get to learn a lot about astronomy. What the subject is, what all can be done. It tells us a complete overview of astronomy, and provides us a lot of insights and helps us a lot to choose our career. Which field of astronomy do we want to work on? So these questions, the best place to answer these questions is the first year of the PhD, which is the coursework. So there, my primary interest was always the stars, as I already discussed. In IIA, there are few individual departments like stellar astrophysics, extragalactic astrophysics, theoretical sciences. So I always look for an opportunity to work on the life and death of stars. And in this, for the first year of the coursework, I met Professor Aruna Goswami, and I worked under her for the coursework project on the variability of carbon-rich star, hydrogen-deficient star. And after the completion of the coursework, this brief introduction to the data analysis of astronomy provided a perfect launchpad for my research work. So till my MSc, I had no experience of direct research. The master's project for me was on fluid dynamics, a Faraday instability. So it was completely theoretical, And after the PhD, it was like being plunged into the sea and with no land on site. So what do I do? With this huge amount of data, and my computing skills were really poor. So I had no idea what to do. So that was the first big challenge, was to handle big data, to analyze big data and come up with some results. Even before that, the first difficulty was choosing the supervisor or choosing the field. So once I decided on stars, and I talked with several people, faculty in the institute, and then I found the problem given by Professor Shivrani Tirupati to be very interesting. It's called Galactic archaeology, or in more general term, it's called near field cosmology. So what exactly we do in this field? Here we look for the history of the formation of our galaxy, or the Milky Way. There are two modes of looking back in time. One is we go and look at events at high redshift. What is high redshift? It means closer in time to the Big Bang. We go back in time and look at objects which are formed early, which are formed at large distances from us, closer to the time of the Big Bang. There is another way to look into this problem, and that way is the one that we pursue. That is, look at the local Milky Way field. The galaxy of Milky Way is formed by a hierarchical merging of several substructures, which are formed very early in time. A large fraction of these early structures still survive in the outskirts of the galaxy. They are older population of stars, older stellar systems like globular clusters. Globular clusters are globe-like formations of star in a spherical shell containing millions of stars. The other is satellite galaxies. These satellite dwarf galaxies also populate the outer region of a Milky Way. If you look at that picture of a Milky Way, you see a disc-like structure. Apart from the disc, there is a complete spherical distribution of stars, which we often ignore. This is called the halo of the Milky Way. So the older population of stars, the older systems, all populate this Milky Way halo. So the problem we probe is we look at these systems. They are called metal poor, as ancient stellar populations are formed primarily from the pristine matter before the heavier elements came into the universe. They are formed in the early universe. So they are devoid of the heavier elements. So we look at the systems, we look at how the elements in these systems are formed, and we try to probe the astrophysical conditions, the origin, the build-up of the entire Milky Way system. And this Milky Way system is like an eye into the entire universe, because each galaxy we see has formed in a similar manner. And the Milky Way is the galaxy that we can study to the best possible details. So apart from that, the other interesting problem we probe is how the stars form. How the stars form, and how the stars evolve, and how the stars explode as a supernovae. So the first stars that pollute the universe were entirely out of hydrogen and helium. We know in Big Bang nucleosynthesis, we can produce only hydrogen, helium, and traces of lithium. So the first stars that came, that lightened up the universe with its photons, are the ones which are formed of hydrogen and helium. But the stellar evolution, the hydrogen burning inside them, produce the heavier elements. Like triple alpha reaction implies 3 helium nuclei combined to form a carbon nuclei. This way, the chain advances by hotter and hotter processing in the stellar interiors, and the heavier elements are all formed inside the stars. Today, whatever element you see, the wooden bed you are sitting on, the wrought iron chair you are sitting on, the food that you are eating, the carbon atoms in your body, the oxygen that you breathe, whatever you use, whatever you touch, whatever you see, all individual atoms are synthesized inside a star. So remember, always in your daily life, everything that you see or touch or feel was once inside a star. Anyway, so the first stars are made of hydrogen and helium, and they produced the heavier elements. So as the time went on, the amount of heavier elements went on increasing. So how do we study these older populations? We study the stars that have lesser amount of heavier elements and larger amount of hydrogen and helium. So this is a probe, this is called metallicity. This is a probe to look at time as an indicator of formation of the systems. So we look at the stars that are formed subsequently after the first generation of stars. The first stars that are formed are still yet to be found in this universe. But what we can easily find is the stars that are formed right after the explosion. Once the first stars explode, they eject the materials into the local ISM and they get mixed, and the metallicity of the ISM increases. The next generation of stars that form will be of a higher metallicity, and this process goes on, and the sun that we see today is of higher metallicity, and they contain elements from several generations of stars. And that's why sitting in Earth you find elements like hydrogen as well as heaviest elements like thorium, gold, diamond, everything you find in Earth. The only reason is it's a result of recycling of several generations of stars. So we study these, we take this as a probe to study the older stellar systems. We probe into how the galactic structure was formed, how the Milky Way halo developed, and how the stars evolved, starting as a globe of hydrogen and helium and ending up as a supernovae or a neutron star. We also probe other questions like what exactly was there even before these stars were formed. There are several elements called neutron capture elements which cannot be produced in the stellar interiors. They can be produced only in exotic processes like supernova or neutron star merger, producing a massive explosion. So these elements, when we study these elements, they tell us about the pre-enrichment of the universe, of the local universe that was there before the formation of these ancient structures. We also do kinematic study. The subject is called chemodynamics. We take the proper motions, stellar motions, and then calculate the origin of these systems, or the stellar streams and other structures that we find in the Milky Way halo. So with these big questions, and looking at the big picture, this fascinating subject to probe, I took up research in this field, but soon found out that everything is not so fancy. To look at, things are very rosy, but when you go down deep into the subject, it's a rather difficult one to probe. It takes a lot of time, a lot of effort that has to go into each individual study. So, doing a good research work, the first challenge is to be systematic, to collect all the data, to write proposals, first of all to write proposals to get good quality of data, to acquire that data, to analyze that data, to compare it to literature, and to come up with the new exciting results. So one has to be very systematic in this study. So to start off, Shivrani used to be very friendly, and so I always got very good suggestions, very good help from her. So she used to tell me like, do this, try that, and I got complete freedom from my supervisor to do whatever I want, to discuss anything I want, to come in the institute or stay at my hostel. So I had complete freedom throughout the duration of my PhD. And she was also very inspirational. She gave me several books, several papers to study, and whenever I had a doubt, she always had an answer to my questions. So that was a very wonderful thing that I had throughout my PhD. Apart from her guidance, I also got help from Professor Sunetra Giridhar, who taught me about learning techniques with spectroscopy using IRF. I also got great help from Professor Aruna Goswami and Professor G.C. Anupama. So combining all these things, my PhD was a wonderful experience. Like learning it the hard way. The one thing one should always remember is never to ask these small questions to everyone for help, and rather finding it out by oneself. That was the first training that I got. Prior to this, anything I was stuck at, I used to go to a teacher or a friend and ask a question. Now here in PhD, the questions that I'm stuck at, nobody has an answer to. So I have to Google, I have to read papers, I have to go through books, I have to talk to my supervisor and find out the answers. So the first difference in being a master's and doing a doctorate study is finding answers to questions by oneself. Keeping this in mind, the journey went forward. The first hurdle again came was the comprehensive viva. That was at the end of 2 years. I had hardly had any result with me, and I was pretty tense like how things would go. Again, Professor Shivrani stepped in and said, it's not only the work that they're going to look at, but also what you've learned over the last 2 years. And yes, that's exactly what happened. I had very little work to show, but the things went pretty smoothly. And after that, I had large amount of data coming from the Hanley-Ishel spectrograph that was newly commissioned at the start of my PhD, and I had large amount of data from that. So now I had data, I learned the analysis, I did the analysis, I got some good results, but the next thing is to write a good paper. And it's always a very difficult task to write the first paper in proper scientific words, using the proper scientific terms, and citing the most important papers of our field. So that took me almost a year to write a good paper. I used to discuss with Shivrani several times, and each time she had a suggestion somewhere to improve things. So my first paper took almost 1.5 years to come up, and after I submitted it, it took another 6 months before it got published. So after the first 2 years of my PhD, doing the first draft and publishing it took another 2 years. So this is an example that things may not always be very smooth. You may face delay at several events, but one should always keep learning. Keep learning the tools, keep struggling with yourself, keep struggling with the things around, sit day and night, work on it, and one will always find a solution to that. What I have realized during my PhD was that doing anything for the first time is always the toughest. Be it writing a research paper, be it analyzing the data, or be it attending a conference to present my work. Before the conference, the first time I would present my work was in ASI, and the heart always beats a lot faster. You never know what to expect. You have all sort of doubts in your work, and you expect all sort of questions in your work, and you are never confident. So the heartbeat goes faster, you keep sweating, you're looking at the watch. But ultimately, once you go through that first time, things will become very smooth, and it's very fun. And overall, my stay in IIA has also been wonderful. Like, the community is very friendly. In the hostel called Bhaskara, we have students from all over the country. Every region, every state has someone to represent that in our hostel. And we celebrate all the festivals, starting from Onam to Durga Puja to Christmas to Ugadi. We celebrate all the things together. There's always someone doing some activity, and we get males who would like to join. From badminton to cricket to movies to theatres to drama to festivals to just street writing, street painting, playing football on the streets. Anything and everything you want, you get someone to accompany you in IIA. The student community is absolutely wonderful. Even the faculty are very friendly, very cordial. You can always ask for help. Everyone is eager to help you. And the wonderful campus, the large granaries. So combining everything, it was a wonderful experience. The food was one thing that we always fought on, because due to the presence of community from all over India, there is always a preference of which type of food would come up in the menu. So every 2 months the menu would be changed, and every time there will be voting, and eventually there will be a fight every time during the vote. But it's all friendly. Everyone fights with a smile on their face. So it's an absolutely joyous experience to be in IIA, to be in PhD, to complete the research at such a wonderful place over a span of 5 years. So finally I submitted my thesis in early 2019, April 2019, and my thesis defense was conducted last year in October. So everything ended on a sweet note, and I'd like to thank everyone who were with me, like all the students, all my friends and faculty who helped me during the duration of my PhD. So doing a research has helped me a lot to develop individually as a person or as a scientist. It has taught me to be self-independent, self-reliant. It has taught me to not to be ashamed of telling I don't know. It has taught me to interact a lot better with people, to share the doubts, or to not to be ashamed to share my opinion on any topic that I know of. So these things have helped me a lot to develop as a person. Apart from that, doing a doctorate study also helps in several other fields, and I have also been able to influence a few younger generations to come into research, to find something new, to find an answer. In science, we always ask what, we always ask why, and we don't know the answers. So if the younger people come up, do the hard work, because they can do the hard work if they want. It's not very difficult. It's not something impossible. Anyone who really wants to do it can certainly do it. Working as a postdoctoral fellow, I feel I am a lot more independent, and I don't have to run to get answers on my doubts, or to get answers to my questions, or share anything that I'm stuck with my supervisor. So I am a lot more independent person, and I know how to work, and I can devise problems on my own to work. So these things, I can feel that I'm a lot more mature and well informed of my subject as a postdoctoral fellow. So I urge all of you, if you are watching this video till the end, I urge all of you, the younger people, to come to this field. It's really exciting. You get wonderful results, and you get very, very good data, you get very, very good information, and you develop a lot individually in this field. So if you are interested, if you are really interested in studies, in taking up research, this is a wonderful avenue. You can always get into IIA. There are engineering departments as well as science departments. You can take whichever stream you want. You get complete freedom to work for several years, and you get sufficient time to establish yourself as a researcher in your field. So with this, I come to the end of my science story. Thank you for your attention.